Welcome back. This time we've got an Easter wind spinner. It's a 3-blade Savonius wind turbine that we've repurposed to look like eggs for Easter. We've got fully 3D printed bearings. They're print in place, no support as always. The whole thing's made out of PLA. It's got a cool clamp that lets you clamp it to a railing and get it out in the wind. Let's take a look at how this works and how we designed it. We've got a 3-blade Savonius wind turbine, and we've cut all of the blades to look like eggs for Easter. These are drag style wind turbines. So it is wind flowing around this surface that makes it spin, and then the curvature also kind of serves as a deflector. So as this is turning through the wind, we're deflecting some this way, which will help turn it. And then everything we can collect in here pulls on the wall and it makes this thing spin. If we hide this, we can see inside we've got 2 hexagonal bearings, and the wind turbine just drops right over the top. We sit on the inner race in here. So this is our clamp that's going to hold it onto the railing, and we're holding this up in the air. So there's a socket in this that holds the shaft and makes sure that the inner race can't spin. It's on a hex socket too, like this. They're both the same. And then if we cut this in half, we can see inside. This is how these bearings are made. We've got these rollers. There's a bunch of them. I think there's 10. And they roll around the inner race and the outer race, these circles. But when we print them, we use this overhang feature. So we create an interlock, and they can't come apart. So the weight of the windmill is really carried by this surface and that surface and all of the rollers right here. And then they all just spin around, and they spin very freely. This is the spacer that just keeps them apart, and then the hex shaft down the middle. This is the moving part of the clamp, the moving jaw. And in order to make it work without support, we split it in half so that we could create this feature for the nut. So this is an interference drafted feature they push together, kind of like a Lego. And then when we spin this guy, actually, if we look at it over here, this is the assembly. When we turn this, it will move. When we turn the nut, we're interfacing these threads to make it turn, and then this face pushes against that face to go up, and this face pushes against that face to go down. And then we just squeeze a railing or something between these faces and get this thing in the wind. We'll see it spin around. It does pretty well. Here's our build plate setup. We'll start with the windmill itself. We're going to put it right down on its base, and there is an overhang feature in here that we can print. That's what's going to let it sit on the outer race of the top bearing and spin. So set that guy up like this. We'll put the spacer on its end so that it will form all the features we need. The nut's going to lay on its side, and we have a 90-degree thread profile in there so we can print the overhangs without any trouble. The shaft, we're going to lay flat on one of its sides for strength. This will both make it stronger because we have the filament lines will be long and continuous in the direction we need strength. And we also won't have to print a tall, skinny thing that might tip over. We looked at the bearings and how we formed the interlock, but these just lay on their side. They'll print in place. And as soon as you pop them off the build plate, if you hold the middle and spin the outside, they'll be rolling. You might want to print slow for these just because precision's important, but there's generous clearance in them. They're big rollers. They should stick to the build plate without any trouble. We've had 0 problems with them. They just print and work. The jaws, we're going to put the socket facing up and the post facing up, and then these just print with no support. And the last piece is this base. The socket has a peaked roof when you lay it down this way, so we can print that overhang. And we've got the threads sideways so that we get the strength continuous filament in the threads, and that way we don't just break them off when we're trying to tighten this down. But set your build plate up like this. 2 walls for this one. We really don't want extra weight, and we don't need the strength, and 15% infill. We did everything out of PLA, and we've had great luck with it. Here are all the parts. So we've got these bearings. They should spin off the print bed. We're going to start with the threaded piece of the clamp, and we'll put, this doesn't matter, you can start with either side, but put one on, then put the nut, and thread it, and just get it started. And now we're going to take the other side, fit it over the end, and then bring them together and snap them together. So now the jaw moves with the nut. So as you tighten it, these 2 surfaces will come together. This is how we're going to clamp it to a railing. The next thing is we're going to install the shaft in here. It should just drop in this hole. And then put the first bearing on. And it's going to come right down to this raised surface here, and the inner race will touch here. So then the spacer goes on over it, right down to the other side of the inner race, and then we're going to put on the last bearing. And it should sit flush right at the top. So that's how you know everything's correct. And the last thing is we're going to line this hexagonal hole in the bottom of the windmill with both of these bearings. So get the first one started, and then you can kind of work them down, get the last one in, and it should sit there, and now it should spin. And if we put it over a railing or something and tighten this guy up, then we can leave it out in the wind and wait for it to spin.